All right, now this introduces a new level of, a new layer onto our solution procedures over here. This is going to require a new tool from our toolkit. And what happens, what we have here is cosine squared theta is equal to sine squared theta plus 1. Again, we're solving from 0 to 360. Cosine squared theta is equal to sine squared theta plus 1. Now, this doesn't factor the way it sits. It's difficult to isolate because we have different... One thing that can help to do is obtain a single function. If you have an equation where there are multiple terms with different functions, it might help to use some of the identities that we know. That's one of the reasons you have these identities, so that you can change this into a different form. Now, what do we know? For example, do we know an identity involving cosine squared? Do we know an identity involving sine squared? Well, the basic Pythagorean rule says we know that sine squared plus cosine squared is equal to 1. And it doesn't matter which one you pick. This is pretty much symmetric in either of them. So what I'm going to do is this. If I take sine squared and move it to the other side of the equation, I have cosine squared is equal to 1 minus sine squared. I can replace this expression with 1 minus sine squared. Now, we're not there yet, but at least we have a single function in the game now. We've eliminated some of the noise, and now everything here involves sine. You could have just as easily moved cosine over and replaced the other function. I just chose cosine to replace because that's the first one that I encountered here. Very often there are multiple ways to solve this. In this case, this is what I'm going to go approach with. Now, the next thing is, can we combine terms? Can we sort of clean all this up? See if we can get it equal to 0 so we can use our procedures. All right, so let's see here. What can we do here? We can add, can we combine the sine terms? Can we say, I'm going to move this sine squared to the right-hand side. So it cancels over here. I have 1 is equal to sine squared plus sine squared is 2 sine squared. Plus 1. And now what can we do? Well, can we get rid of these 1s? Now, look, we can get this thing equal to 0. That always helps. Let's see. Subtract 1 from both sides of the equation. We have 0 is equal to 2 sine squared theta. We're making headway here. Again, we're on the way. We're trying to obtain basic equations. And look, we can get rid of this 2 even. You don't necessarily need to, but look, we can get rid of the divide both sides by 2. 0 divided by any non-zero value is still 0. So what we end up with is sine squared theta is equal to 0. And that's not yet a basic equation, but we know how to get rid of square root. The way you get rid of square root is, a square rather, we know how to get rid of square. You take the square root of both sides of this equation. Get rid of this. So if I take the square root of the left-hand side, now strictly speaking, anytime you do square root, you need to introduce plus or minus. But the nice thing about having 0 over here is positive 0, negative 0, they're both 0. So the positive negative becomes irrelevant only in the scenario where you have 0. Square root of 0 is 0. Square root of sine squared is sine. And now we're back to a quadrantal angle. This is one of the basic equations. All you need to do to solve this is know what the graph looks like. How do you know it's quadrantal? Sine, cosine, tangent equal to 0 is quadrantal. Sine, cosine, tangent equal to 0 is quadrantal. Sine, cosine, or tangent equal to 0 is quadrantal. Excuse me, sine, cosine equal to 1 or negative 1 is quadrantal. This is certainly quadrantal, so all we need to do, there's no quadrant check, there's no reference angle. Quadrantal angles do not lie in quadrants. There's no quadrant check. They do not have reference angles. There's no reference angle required. All you do is look at the equation and say, where does sine cross the x-axis? Where is sine equal to 0? Well, there's one, there's one, there's one. But we don't want this one because we're using an open interval on the right endpoint. And even though this is in radians, we need to express our answer in degrees. So it would not be correct to put 0 in pi because we're asked to solve in degrees. So translate to the degree language. So immediately from knowing what the graph looks like, and again, if you can do this without drawing the picture, so much the better. Look in your mind's eye and see the cosine curve. Where does it cross the axis? It crosses the axis at theta equal to 0, which is the same radians or degrees. But it also crosses at pi radians, which we know to be 180 degrees. We would have used 360, but we're having an open interval here. And so that's what we want.